Ready to do your first V-carve in Carveco Maker? Then keep watching. Hello and welcome to James Dean Design, specifically my Carveco Maker series, where I'm going to be walking you through all the different steps to get you up and running within Carveco Maker. And if you are new to the channel, hit that subscribe button to get all the latest tips, tricks, tutorials and reviews. Now in today's episode we are going to be creating our very first V-carving. I recently did this sign and thought it'd be a nice little introduction project to get people up and running in terms of doing V-carving. Now we're going to be covering a couple of different things in today's episode. First, obviously, we're going to create our design, learn how to import an SVG, and then we're going to move on to discussing some of the physical considerations around V-carving, such as the shape of the V-bits versus the depths that they cut at. We're going to move on to take a look at Vector Doctor as well and see some of the advantages to using that and how it can clean up our vectors before moving on to actually generating the toolpath. Now in the toolpath generation as well, we're going to play about with a few different settings, see the different outcomes of them, so ultimately you can really start to understand the different settings within the V-carve option. So the first thing we're going to do is move over to the PC and obviously get our design generated. But do remember, this is part of a series, and some things that we've previously covered may be in the beginner's guide, which you can find a link up in the corner if you've not yet seen it. But for now, let's jump onto the PC and start to get some work done.
So we've got Carveco Maker open and we can clearly see I have the artwork from the last time this was created. We can also see I need to do an update, but I'm going to ignore that for now and carry on with the tutorial. So we're going to click New Model, and the dimensions from the last project are already saved, which is the same as we are working to today, 290 by 350. We're going to leave the resolution at maximum, and the origin for today's job is the bottom left hand corner. So we'll click OK and generate our work area. Now the main element of this sign is obviously the image of the zebra, and this is downloaded off the internet as a pre-created vector. Basically what that means is somebody else has done the hard work and we're just going to be using it within our file. Now there are a couple of ways to import your vectors into Carveco Maker. One of the easiest is to simply find the file in your folder system and you can potentially just drag it on, release it, and it will import as we can see here in the background. Now for the moment I'm going to delete this and I'm going to show you the slightly longer way, just because it does have one additional feature that can sometimes be very useful. So we're going to come up to the vector menu, select import, navigate to that same folder and we can see these same files again. Now the first thing I'll point out is these are all different types of vector files, so don't be alarmed if you do see them named differently. They will all work in Carveco, and for a full list of file types you can expand this menu out here and all of these different file types will work within Carveco Maker. You're probably thinking, what is the differences between them? Well, basically they hold different levels of information within the files. An SVG is often one of the simplest forms of vector files, and that is often the one that I use because it can make life easier when working with it in Carveco Maker. So I'm going to select that for now. Now the feature that is different when using the method we are showing now is you get this option around layers towards the bottom. Now the reason this is important is perhaps if you are using a more complex vector that is built up in layers, you can preserve those layers when importing it. You can maybe generate these as a new layer instead of the current layer. So basically you just have a few different options when importing the vector. But for the purpose of today, this is a single layered vector and we're just going to leave it on the current layer and click open to import it. Now we can see it's dropped it over here on the right hand side. So what we're going to do for ease is hit F9, pull it into the center of the work area, and then going to zoom out. And we're just going to grab one of the anchors in the corner and resize it down to a position that I am happy with. I'm going to pull this down here a little bit, and then I'm going to zoom in just to make this a better view, and maybe shrink that down just a little bit more. Resize to the full work area, and I think I'm happy with how that is sitting. So we're going to click off and we can now see that vector is in place ready for us to work with. Now, as a small spoiler alert, I know this vector has one or two issues, and these will get flagged up later on, but that is why we're going to run through the vector doctor as well to help us solve these issues. But for now, the next thing I want to do is put the text in place for this sign. So we're going to come over to the type tool, and we're going to select the type tool up here in this top left area. We're going to type out Z is for ... We can see this is typing out in what is known as a serif font. If you're unfamiliar, a little bit of typography knowledge here. A serif font has feet on the bottom like this where they kink out, and a sans serif font has often more straighter letters that do not have these feet. I often find the serif fonts are nicer when doing V-carves. It just adds a little bit of extra character. So we're going to stick with this for today, which is Times New Roman. Zoom back out to fit the area, and what I actually want to do is make this just fill up a little bit more space. We can either do it by highlighting the font and changing the sizing over here on the right hand side, or we can simply just grab one of the anchor points corners and stretch it out to make it as big as I want it to be. I'm going to move this over slightly, and I think I'm pretty happy with the position of that. Now remember, with text you need to click the create button to make it permanent. So with that is made, I'm going to click off it, and we can see this is now starting to build up. We're going to put the last bit of text down here in the mid area, so we're going to come back over to the type tool, click around here, and we are going to type stripy horse. I'm happy with the size of that font, so again I'm going to click create. But one thing I want to do at this point is to make sure both of these pieces of text are aligned at the same point on the left hand side. So I've selected both of them by holding down the shift key. I'm then going to come up to the vector menu, come down to align and select left alignment, and what we should see is both of these are pulled to the left to be in the same left hand position. You just seen that jump slightly over, and it now means that the Z edge is aligning with the text over here, and it just visually looks a little bit cleaner. If I click off that, now essentially we have the basics there of the sign we are going to be working with.
So with the basic design done, we're now going to take a look at some of the considerations that you need to give when using V-bits, because they do come in at different angles, different sizes, and ultimately can cut at different depths. So there are a couple of little things we need to think about before we actually start getting into generating the toolpath. So we'll take a look at those now.
Now I'm going to use some fairly basic illustrations to show this information, but it's often the best way to get it across. Now there are three things we're going to cover. The first is the width of the cut versus the depth of the cut. If you are using something like an end mill, it doesn't matter if your cut is 1mm deep or 10mm deep. Due to the nature of the bit, the width of the cut will be exactly the same no matter what the depth. Now when it comes to V-bits, it is a little bit different. Obviously, because you're essentially cutting with a triangle, the deeper the bit goes, the wider the cut is going to be. Now for example, on this 90-degree V-bit, obviously if we're cutting at 1mm deep versus 2mm deep, the 2mm deep is going to be twice as wide as the 1mm bit, and so on for 3mm deep, 4mm deep as the bit will go. So ultimately, the deeper the bit is going to cut, the wider it is going to cut. But also remember that if you're using a smaller machine, then the more pressure is going to be put on the bit, because there's going to be a lot more force on the bit itself. So sometimes you may have to make a decision as to what you are trying to achieve, whether the width of the cut is important or the depth of the cut is important. Next is the angle of the bit versus the width of the cut. Now all these are different angles and they are all cutting at the same depth, but what we can clearly see is obviously they are cutting different widths based on that same depth. And again, it is just something to bear in mind that a wider bit is going to naturally give a wider cut even at the same depth. And again, referencing what I said earlier, that can often mean more force on the bit when it is machining. And finally, we have full depth cutting versus limited depth cutting, or traditional versus modern. Now that both scenarios achieve exactly the same width of cut, but they go about it in two different ways. On the left hand side, the more traditional approach is it will just take the bit deeper and deeper until it achieves the desired width of that particular cut. Now obviously, depending on the angle of the bit you are using, this may need to go very deep in order to achieve that width. So that is one of the biggest downsides basically is that to use this approach, you ultimately need to use thicker stock, and obviously depending on the design that you are doing. But the plus side is you do get the traditional V-carve style that people expect to see. Now on the more modern approach where we set the limit of the depth, instead of vertical movements, it is more horizontal movements. So it will do horizontal cuts. So you still get the same V shape on the side, but not the full triangle that you would traditionally expect to see. But the plus side is to this, we can use thinner material and ultimately do wider widths without needing to worry about the depth. So both approaches do have pros and cons, and it is ultimately about selecting the right approach depending on the bit you are using, the job you are creating, and the thickness of the material that you want to work with. So if you were unfamiliar with V-bits, hopefully that's just given you a better explanation of things to look out for and what to bear in mind when creating your pieces. So let's move on to generating the toolpath for this particular job. The first thing we're going to do is select all of the artwork simply by pressing Ctrl A. We're then going to find the V-bit carving toolpath. Now we can either go up here to the top menu where it is, or we can click on the toolpaths option on the right, and again they all appear down here where we've got a few more options. So we'll select create V-bit carving toolpath. And this is where we start to get stuck in with creating everything that we need. Now we're going to work on selected toolpaths for the moment. Obviously we can use just the zebra which was imported, or we can use the default layer. We're going to remain with selected vectors for now because obviously we have all the artwork selected we want to use. The start depth is 0. This is the top of our material. Obviously if you are doing a V-carving in something like a bowl that has already been machined out, then you would set the start depth to where you want it to actually begin cutting. But as I say, for this particular sign, the start depth is the top of our material, so this will remain as 0mm. The next option is limit tool maximum depth. Now I just explained the way V-bits work. When it tries to span a gap, it will continually go deeper until it achieves the width that it is after. Obviously if you have something like a very narrow V-bit, such as maybe a 20 or 30 degree V-bit, it is going to try and plunge that very deep in order to bridge what may be a fairly narrow gap. However, we can minimize the way that works with this particular option. Obviously, if you turn it off, it will define the depth of the cut based on the bit it is using versus the width it is trying to cut. So essentially, you have no control over it. The computer or the software will decide how deep that cut is going to be. But if we turn it on, we can control this. And for the purpose of today, we have it at 8mm deep. So basically, that means no cut will come out more than 8mm deep, and ultimately this is just good if you want to set a specific depth for a cut, if you're using thinner material and don't want it to go too deep. So I often find this is very useful to use. As always, we leave tolerance at the minimum setting of 0.025. we hardly ever touch that. And next we get to select the carving tool. So we're going to open this up. We have our tool database to select from, and for the purpose of today I'm going to be using my Imana 90 degree V-bit tool. So I'm just going to expand this out and find the 45711 90 degree V-bit. There we are. Now before I click select, I'm just going to go into the edit menu to show you some valuable information. Now obviously the parameters of this bit are already set in the tool database. We have things such as the angle of the bit itself, the overall width of the bit or the full diameter of it, but crucially we also have this flute length illustrated on the diagram here by the letter C. This is the maximum depth this bit will actually cut. So ultimately we can't go no deeper than this without starting to then get straight edges or ultimately causing ourselves some issues. So as we can see, this can go up to 8.7mm deep. Now you will have seen earlier I set the maximum depth to 8mm, so we're almost topping out as deep as this bit can actually go. So we're going to click OK, and then we're going to click select, and it will load that tool in so it thinks we are carving with this particular 90 degree V-bit. You can expand the menu out should you want to control the various settings. Now the step over is something I'm going to come back to very shortly, because if we are setting a maximum depth, that means that it will not go deeper than a certain amount. That can sometimes mean that on wider areas it has to do it in multiple passes, and the step over is crucially how fine that detail will be. So as I say, I'll come back to this shortly, but for the purpose of today I'm going to leave the rest of the settings as they have loaded in. Now I'm going to skip over the next section, and the reason for this is because I know it will not work at the moment, as I mentioned earlier, because there are some issues with the vector. So we're going to come down and we're also going to skip past the roughing tool, and again I will come back to this a little bit later. Now I know it seems like I'm skipping over things, but what we need to do very shortly is correct the vector, and then we can come back and have a play about with all these different settings. I'm going to come down a little bit further. We're just going to define the material, make it 18mm deep, click OK, and then we're going to give it a name of zebra. We're going to click calculate now, and what should happen is a warning message is going to pop up telling us there is an issue. Ta-da! Big surprise. Now basically what it's saying is there's some issues been found in the vectors itself, and basically use the vector doctor to try and correct those. So we're going to click OK. Obviously nothing has been generated at the moment because it knows there is an issue. So the next step is to come over and use the vector doctor tool, which is this big green symbol with the plus in it highlighted saying vector doctor. So we'll click that and open the menu up. Now one thing I'm just going to mention at this point is because Carveco is such a powerful software, it gives you lots of options when it finds errors. There's some more elementary software out there, for example, may just try and make these decisions for you. Now in one hand that does make things easier, but equally it is taking the power and decision away from you and may choose to do something that you do not want to happen. This is one of the reasons that Carveco is so powerful and is so good, because it gives you the power to control things as opposed to making those decisions for you and potentially doing something you do not want. Now the vector doctor is about allowing you to control those issues within your vector file and ultimately correcting them, deleting them, or simply just identifying them. So I'm going to leave the curve tolerance as 0.01. I'm going to skip this section here. This is about searching for specific things within vectors, such as the way things are grouped, the length of them, the size of them, that type of thing. We're going to come down to this one that says identify problems. Now coincidence points are something that I will leave off. It is about when lines are getting a bit too close to each other, but for the most part you don't need to worry about them. So leave that off and just make sure vector intersections is turned on. What we're going to do then is click identify, and we should see a series of circles appear on screen. Now if I zoom in on where all these circles are appearing, what we can see is we have two different colors. We have green circles and we have red circles. So we'll start with the green circles to begin with. Now Carveco defined this as being a duplication of vectors, which is sort of correct, but it's not entirely correct. What the green circles usually represent is vectors overlapping one another. Now this can be a duplication. It can also simply be two lines touching together, and I'll show you the different examples here. So where we've got this group of green circles going on down here, if I zoom in and just reposition this in the center of the stage, and if I zoom in on this quite deep, what we can see is this particular shape has a lot of green circles around it. So usually if it has more than one green circle, it means it is a duplication. So what if I click off this and click on this particular shape? Now what we can see, if I drag this out to the side, the original shape remains, so there is a duplication of vector there. Now the easiest way to solve this is to simply delete. Now a method to specifically just find duplicated vectors is to use the option over here where it says duplicates. So if I undo those last two moves that I did, now as I say, we know this is a duplicate vector that is highlighted here, so I'll click off it, just select duplicates, and there it has highlighted the duplicate vector. So we can simply hit delete and it gets rid of that, and we can see there is still the same vector underneath. Now ultimately, if we clear markers, get rid of that, make sure everything is selected again, Control A and click identify, we can now see no green circles have appeared, so we have solved that particular issue. However, if we zoom back out to the full size, zoom back in where the other green circles was, now what's the issue here? This obviously isn't a duplication because it would have detected it. This is where we have two vectors overlapping. And the more I zoom in, the more this becomes apparent. The one vector on the right hand side, if I move this over slightly, is simply intersecting with the other vector at the side of it. So what we can do in this scenario to tidy this up is zoom out a little bit. And all I'm simply going to do is hit the right arrow key to move this across until both of those are not touching. Now again, if I zoom in, we can see there is a clear gap between them. I will click Ctrl A, make sure everything is selected. We will clear the existing markers and click Identify again, and we can now see all of those have disappeared. So if we zoom back out, we can now see that all of the green circles have been corrected, and we only have red circles left. So the red circles are basically where the vector has a loop or is intersecting itself. And again, Carveco Maker doesn't know how to interpret this and is giving you the choice to correct the situation. So if we zoom right in on one of these, hopefully we should just about be able to see what is going on here. We can see the two lines coming down from the top, and also ultimately they end up twisting back over each other, and you get this bit of a loop going on, and that is basically what the red circles are identifying. So the way we're going to fix these loop issues is to come down on the bottom right hand side where it says Fix Problems, select Remove Vector Loops. Now the percentage here is about how big of an area you want it for detecting or removing these loops. So I usually keep it pretty low at 1%. Now we're going to click Fix Problems. And what you saw is that loop then got deleted. So it gets rid of those areas that are causing the issue, and hopefully when we click Clear Markers and Identify, now they have gone. But if we zoom back out, we can still see there are one or two issues going on up here. Now obviously I've deliberately done things in this vector to highlight the various issues you might see within your vectors, but hopefully you will not get as many of this on your particular projects. But if we zoom in on this top one right here, what we can see is we've kind of got this bit of a separated vector going on that isn't really doing anything, and ultimately this is causing a bit of an issue for the job that we are trying to do. So if you have a vector like this where you end up having these little flaky bits on the design, then there should be one somewhere else down here, for example, and it's because they're essentially getting in the way and say it doesn't know how to interpret them or what to do with them. Essentially, it's a bit of a scruffy design that we are trying to correct. So one thing we can do to get rid of these small areas is use some of the select specific vector tools that we've got going on over here. So we're going to use the Close Vectors Smaller Than tool, and this will basically search all your vectors to find ones that are smaller than a specific area. In the example of what we have on screen, it's about looking for those little scraggy bits of vectors that essentially can't have anything done with them. So we're going to select this tool. Obviously we've got the setting quite small at 0.1 millimeters squared, so basically hardly anything at all. And when we click this search feature, you will see it has highlighted all those issues that are pinpointed in red. Now what we simply do at this point is hit the delete button. It will get rid of those. We zoom back out. We can still see that the markers are in place, but we'll press Ctrl A again, click Clear Markers, and then click Identify, and that should be everything. If I zoom out to the full extent, we now have no issues on our vectors. Now before we go back to doing our toolpath, I'm just going to quickly open another instance of Carveco Maker that I've got to open, and I've got a bit of a silly shape drawn here, and I'm just going to show you another possible workaround to get rid of some of these intersecting loops instead of using the vector doctor, and this is to use the offset tool. It was a tip I picked up from one of the Facebook Carveco groups. Now if we zoom in on this little bit of a silly shape that I've drawn, we can see we've got these intersecting loops going on, and just to prove that, if I click Identify, it's obviously identifying the issue going on here. If I zoom back out a little bit, obviously the shape is selected. We're going to come up to the vector option. We're going to come down to the offset tool. Now what this will basically do is create an offset vector of the existing one you have selected. So what we're going to do is set the offset distance to something minute like 0.001 millimeters. So obviously that is tiny. We're going to leave it selected as outwards. We're going to leave corners selected as radius, although in this case we could select sharp and we'd still get the same results. And we're going to make sure this is selected Delete Original Vectors. Now once I click offset, what it should do is get rid of these little intersecting pieces at the top of the peak. So let's try that now. And there we'll go, it's cleaned up the vector. So just to prove this, we'll select the vector again, click clear markers, click identify, and they've all gone. So there is an alternative route to sometimes clean up your vectors instead of using the vector doctor. Let's say it does work a lot of the time, but not all of the time. So that is one thing to bear in mind. But if we go back to our original artwork now, and we'll carry on with the toolpaths.
Now, a common question that often comes up is, what V-bit should I use? The truthful answer is, well, all of them. It depends on the particular job you are doing. You may want a nice wide cut that is shallow, so you may go for something like a 90-degree V-bit. But equally, if you're doing text and you want nice depth to it, you might go for a much more acute angle like a 20 or 30-degree V-bit. What I would strongly suggest is go through your tool database and select different ones and simulate them. Select a 90-degree bit, simulate it, see what the results look like. Select a 60-degree V-bit, do the same. Start to gauge the different outcomes of different bits on your material, and you'll quickly learn the different effects that each bit will get from certain settings or desired outcomes. So basically, have a play, use the simulator, and see how you get on.
So if I now close the Vector Doctor tool down, and we've still got our toolpath option open here in the back. So what we can do now is click Calculate, and it has generated all of our toolpaths. And if we click on the toolpath and simulate them, we can get them in a 3D environment. So I skipped a few things earlier, but we're going to go back and cover them now we know everything is working. So let's go straight back to the top of the V-bit carving toolpath area and start to work back down this again. Now the first thing that we were talking about was the limited tool maximum depth, and we set this to 8mm. Now if I zoom in on the nose, we can start to see the example of this. Because it can't go to the maximum depth, it has essentially carved it in multiple passes to try and get that flatter area in the middle, because say it can't go as deep as we want it to. But for example, if we untick this and click Calculate now, if we reset the simulation and let it simulate again, we can now see that it's done that in more of a traditional V-carve, where there is essentially a deeper pass within the nose area. So that is one difference and one advantage to this minimum depth, that your material may not be able to go too deep or as deep as the V-bit wants to, so you can control it. Now if I skip a little bit further down, what this information here, the width and depth cut information, it will essentially tell us the widest part and the deepest part of the cut. So if we now click refresh, it will show us that the maximum depth this is going to cut to is 12.3mm. So essentially at that deepest part there, that's going to be 12.3mm deep. And it is also highlighting the maximum width area of 24.6mm. So for now, I will just revert this back to having the limited toolpath on. We will regenerate this. We'll reset the simulation again and just generate it again. So now we've gone back to how we was earlier with these multiple passes going on. And what I said was that we can control this by possibly using the step over. So now we have a step over of 2.61mm, and essentially that means that these will be 2.61mm apart, because that's the step over. So what we can possibly do is reduce this and get a smoother area in this nose part. So let's, for example, bring this down to 0.5mm. Now before I click calculate, the one thing I should identify, like with any type of toolpath, is the lower the step over or the smaller the step over, typically the longer the job is going to take, because it will need to do more passes to complete it. So if we click calculate now, and we redo the simulation again, what we can see now, that is a much finer detail. Obviously the ridges there are a lot less, so we're going to get a smoother outcome in this particular area. But equally, the job time is going to go up as a result of doing that. Now obviously doing this with a V-bit is going to take lots of passes to try and achieve this flat area. Another method to doing this is using a roughing tool. Now obviously a roughing tool takes as much material out as possible before using the main finishing bit to achieve the desired result. But one advantage that we can use the roughing tool here is to use a flat bit such as an end mill to get a flatter surface on the bottom of this area. So in the V-bit carving area, if we come down to the roughing tool selection, and what I'm going to do now is use something like a 1/8 end mill, just a flat end mill. I'm going to select that, click select, and we're going to recalculate this again. You'll see we have a lot more lines going on now because essentially it's doing one pass with the end mill and then another pass later on with the V-bit to achieve the V-bit carving. So we're going to reset the simulation now again, simulate it again, and what we can see is this area here is now nice and flat and smooth. Obviously where it is a slightly tighter area, it couldn't do that because it can't get the 1/8 bit in there. However, if for example we selected a smaller end mill with this, perhaps something like a 1.2 end mill, click select, click calculate again, and you'll see we have an awful lot of toolpaths now. Now obviously the downside to using such a small bit is it's going to do a lot more passes to machine out the same area. But if we reset the simulation again, and what we can see is it's taken even more out of that little area, so the majority of it is now nice and flat and smooth. But ultimately the downside to this is, I say, if we now check the time to machine this just based on the standard values we were using, this is apparently going to take around 8 hours to complete. Obviously that is a ridiculous amount of time for what is a fairly simple carving. So for the purpose of this video, let me just get rid of this. We're going to delete the end tool. We're going to take the step over back to what it was earlier. I think it was something like 2.6 if I remember correctly. Click calculate. Now if we check the time for this, it's down to 18 minutes. So this really is the trade-off here, and it's finding a level that you are happy with. Now obviously this V carving in particular will have this flattened area out, but not all V carvings will, especially if for example you are just doing text. It's not going to have a wide enough area that requires a V carving flatted area. For me, when doing this particular job, I was happy with it having that multiple step over. So I think I reduced this down to about 1 millimeters and worked off that. And that gave me an end result that I was pretty happy with. But as I say, it is all about you and your desired outcome. And also the material you're working with can help to hide some of these ridges. For example, something like softwood that has got quite an open grain with it, it will easily hide some of these ridges in the wider areas. One thing I nearly forgot to cover, which I'm just adding back in now, is step down. Now the reason that this is important because ultimately it depends a lot on the power of your machine. Now as we can see at the moment, this is set to 6.3 millimeters down step down. So basically that will mean where possible, it will cut 6.35 millimeters in one single pass. And if we turn the toolpaths back on, we can see this is highlighted by a lot of this middle area, whereas it's only taking one single pass to achieve the outcome that is required. Now obviously if you are using a less powerful machine that can't go that deep in one pass, then this needs to be a smaller number. So for example, let's say you are using something like, I don't know, maybe a 3018, a 1320 that can only do 1 millimeter depth per pass. So we'll put that to 1 millimeters. And what you'll see happen is when I click calculate now, instead of these areas being one single line, it will be multiple lines where it is essentially taking a little bit out each time, but it is still going to give the desired V-carve effect at the end. It will just take several passes to achieve that desired depth. So if I click calculate now and zoom back in on one of those areas that we were just taking a look at, can rotate this round, and what we can actually start to see is essentially how it works. It's just going to be taking different passes out, working down that V carving to get to the desired depth. So that is one thing to factor in. Obviously if you are using a smaller machine, make sure the step down is a little bit lower, but you're still going to be able to achieve the same effect even using something like a 90-degree V-bit, which obviously is quite a wide bit to use. So just clear those lines back off and go back to a full out zoom version. And that is a very brief overview of doing your very first V-bit carving. Now as I say, it's about going in, playing with the settings to get the optimum result that you are after. One thing I will quickly show you is we haven't really taken a look at the text on this. If I turn the toolpath back on by coming to the toolpath menu and clicking on the light bulbs at the side of it, we can start to zoom in on the bottom of these pieces of text. And you start to get these little feet on them, and we can see the toolpath is putting these nice sharp corners corners in. And this is one of the reasons, as I say, I like to use a serif font when doing a V carving. I suppose because it reminds me a little bit more of old chiseled out stone and how that would have been, so I do like the output from it. But if we turn those back off now, we just see we get this very nice clean V carving, which say is ideal for our very first V-bit carving project. And then obviously with all that done, you continue to export your toolpaths as normal. Click on the toolpaths menu, the save icon, and then save them out using the relevant format for you or your machine.
And that wraps up creating our very first V-carve. Now, as you've just seen as we did on screen, a lot of it is about playing with those settings initially to begin with, to start to understand how things change and the different results. Use the simulation tool. It is one of the great features of this software, and you can start to see how things come out in real time, obviously, before moving on to actually machining your job out. Now, I do hope you found this video useful. If you've not done so already, please hit the subscribe button. Please give it a thumbs up. It really helps the channel. Thank you very much for watching. Final thanks as always goes to my patrons. If you want to get involved for one-to-one help giveaways and early access to content, then check out the Patreon links in the description area below. I will see you all on the next episode.